At 7:42 a.m. on August 17, 1943, a single P-38 Lightning lifted off from a dirt runway at Dododora Airfield in New Guinea. Nothing about the aircraft suggested it would survive the next hour. The pilot was 23 years old, 6 combat missions, no victories. Ahead of him, Japanese Mitsubishi A6M Zeros were already climbing to intercept. The math was known. At low altitude and low speed, the P-38 could not roll or reverse as quickly as a Zero. Every briefing said the same thing: do not turn, do not hesitate. If you hesitate, the timing collapses. On the ground, a technical sergeant watched the aircraft climb away. He had serviced that fighter the night before, alone, after hours. What he had done was not approved, it was not logged, it was not supposed to exist. Inside the aircraft, something was different. The control response was immediate. No pause, no dead movement before reaction. 17 minutes later, 3 enemy aircraft were down. Not because the doctrine had changed, not because the pilot had suddenly become exceptional, but because a fraction of a second had been removed from the system. That fraction had been enough.
Technical Sergeant James McKenna was not an engineer. He was not a test pilot. He did not work for Lockheed, and he did not have authority to redesign anything. In the Army Air Force's system, a flight control change was the highest kind of risk. Engines could be swapped, guns could be adjusted, panels could be replaced, but control cables were treated like a sealed argument. If they were within specification, the discussion was over. And on paper, the P-38's aileron cable tension was acceptable. That was the trap. A tolerance can be acceptable in a factory and still be disastrous in combat. The aileron cables ran long distances through the twin boom layout, through pulleys and junctions, and small amounts of play were allowed. At cruise speed, pilots barely noticed. In hard maneuvering at lower speeds, the play became timing. McKenna had watched that timing show up in the same place over and over. Pilots rolled to reverse, and the aircraft hesitated. Not a full second, a fraction. Enough for a Zero pilot to predict the move, tighten the turn, and arrive where the P-38 was about to be. The formal explanation blamed training. Briefings repeated the same doctrine: dive, fire, climb away. Do not enter returning fight. The problem was that combat rarely gave clean choices. Formations broke. Altitude disappeared. A second attacker arrived from above. A pilot who tried to disengage still had to reverse at least once, and that reversal lived or died on response time. McKenna did what a mechanic is trained to do. He searched for a repeatable mechanical cause. He found it in the cable feel and sound during maintenance, a slightly loose tone, a small, consistent slack. The aircraft were not broken, they were built that way, which meant the fix was not a repair, it was a modification. That is why he should have failed. He had no approved part, no written procedure, no test data, no permission. If the change jammed, slipped, or altered loads in the wrong direction, the aircraft could become uncontrollable. And if anyone above him noticed, the consequences would be administrative long before they were technical. So the only path left was an improvised one, hidden inside the boom, small enough to escape attention. A change that could be installed in minutes, removed during inspection, and denied in a logbook. It was not a plan built for recognition. It was built for the next takeoff.
McKenna's confidence did not come from theory. It came from repetition. By August 1943, he had been maintaining P-38s in New Guinea for 8 months. Every morning followed the same rhythm: fuel, oil, ammunition, control checks, sign the log, watch the aircraft taxi out, and then wait to see which ones came back. He had worked on dozens of aircraft, different pilots, different sorties. The same complaints returned with the survivors. The controls felt heavy in reversals. The roll response lagged when the aircraft was slow and loaded. Pilots described it in different ways, but the pattern was consistent. McKenna understood mechanical systems the way mechanics always have, not through equations, but through touch. He could feel tension through gloves. He could hear it when a cable was plucked. A properly loaded system had a higher, tighter sound. The P-38s on the line all rang slightly low. Factory tolerances explained why. The twin-boom design required long cable runs. Temperature changes expanded and contracted metal. Pulley wear added variance. Specifications allowed slack to prevent binding at high speed and altitude. None of that mattered when a zero was turning inside the aircraft's response window. McKenna had watched pilots return with bullet strikes clustered in places that only made sense if the enemy had predicted their roll timing. Not guessed, predicted. He had spoken to other crew chiefs quietly. They noticed the same thing. No single failure, no obvious defect, just an aircraft that responded exactly as designed and exactly too slowly. The manuals offered no solution. Engineering channels moved on a timeline measured in months. Combat moved in minutes. McKenna also knew something else. Aileron response was not limited by control surface size. It was limited by the delay between pilot input and surface movement. Remove the delay, and the aircraft would not become more agile than physics allowed. It would simply become immediate. He did not need a redesign. He needed preload. A small, constant tension that removed free play without overloading the system. Something light, strong, invisible once installed. That was why the solution came from a scrap bin instead of a drawing board. High-tensile piano wire was already used elsewhere in aircraft control systems. Cut to length, bent correctly, it could act as a passive tensioner without introducing new moving parts. 8 minutes of work. No change to geometry, no change to surfaces, only timing. From a regulation standpoint, it was indefensible. From a mechanical standpoint, it was obvious. And from McKenna's position on the flight line, watching pilots not return, it was already overdue.
The pressure was not abstract. It arrived every morning. Beds emptied overnight, personal gear was boxed without ceremony, aircraft were logged as combat losses with no mechanical faults noted. The paperwork closed quickly. The airfield did not slow down. McKenna kept a quiet count, not official, not written. Pilots he had spoken to, pilots he had shaken hands with during pre-flight, pilots whose aircraft he had signed off hours before they were gone. Some had experience, some did not. The outcome did not correlate cleanly with skill. One pilot returned shaken after barely escaping a zero that had stayed with him through a reversal. Another never returned at all after reporting mushy controls over the radio. Different aircraft, same description. That was the second credential McKenna carried. Not rank or training, pattern recognition under consequence. The official explanations began to ring hollow. Pilot error became a default label, applied after the wreckage stopped burning. It protected the system, it closed investigations, it avoided larger questions. But the pilots who survived were not describing errors, they were describing delays. The environment made those delays lethal. New Guinea forced engagements lower than doctrine preferred. Weather scattered formations. Japanese pilots were disciplined, patient, and experienced in exploiting timing. They did not need superior speed, they needed predictability. And predictability came from the P-38's control lag. McKenna understood the risk curve. If he did nothing, the pattern would continue. If he acted and the modification failed, the result would be immediate and obvious. There was no safe option, only different kinds of failure. Authorization was not coming. Engineering offices were thousands of miles away. Even if approval arrived, it would be too late for the next sortie. The request came quietly, late in the evening. A young pilot asked if anything could be done to make the aircraft roll faster. Not better, not stronger, faster. McKenna did not answer immediately. He told the pilot to return in the morning. That night, the hangar was nearly empty. The aircraft sat cooling under tropical humidity. Inside the boom, the cables still had play. The same play McKenna had felt for months. He worked alone because that was the only way the decision could exist. No witnesses, no committee, no diffusion of responsibility. The wire was cut by hand, bent imperfectly, tested by feel, installed where it would never be seen unless someone already knew to look. It did not add power. It did not change tactics. It removed the lay. When he finished, there was no sense of triumph, only uncertainty. If the aircraft failed in flight, there would be no argument to hide behind, no specification to cite, no doctrine to reference. But if it worked, the difference would be visible immediately, not in reports, in survival. At dawn, McKenna stood on the flight line and watched the aircraft depart. This time, the waiting felt heavier.
The mathematics of the engagement had always favored the Zero. Not in speed, not in firepower, in timing. A turning fight is not decided by who turns tighter in theory. It is decided by who arrives first at the next position of advantage. That arrival depends on roll initiation, roll rate, and reversal delay. The P-38's published performance numbers did not capture that delay. They measured maximum roll rate once the surfaces were fully deflected. They did not measure the dead movement before deflection began. That dead movement was where pilots died. When a Zero pilot committed to a reversal, he assumed the P-38 would hesitate, not because the American pilot was slow, but because the aircraft was. That assumption had been correct for months. If the P-38 stayed straight, it lost positional control. If it turned, it lost the timing battle. Either path led to exposure. Doctrine tried to solve this with altitude and energy. Dive, fire, extend. But doctrine assumed clean geometry and a single opponent. In reality, engagements collapsed into compressed multi-axis problems. One aircraft diving, another climbing, a third arriving unseen from above. At some point, every pilot had to reverse direction, and in that moment, the P-38's delay became fatal. The Zero did not need to outturn the Lightning forever. It only needed to anticipate one move, one fraction of a second. McKenna's modification altered that equation, not by changing the aircraft's limits, but by removing predictability. With the slack gone, the P-38 no longer telegraphed its intent. The roll began when the pilot commanded it, not after the system took up play. That shifted the timing window enough to break the Zero pilot's expectation. The math flipped. The Zero pilot committed based on an assumption that was no longer true. By the time he adjusted, the aircraft was already somewhere else. This did not make the P-38 superior in sustained turns. It made it dangerous in transitions. That distinction mattered. Japanese pilots had learned to fight the P-38 as a system. They knew when it would respond. They knew when it would not. McKenna removed their certainty. From the cockpit, the change felt simple. From the opposing aircraft, it felt like a mistake. The trap had always existed. The difference was who fell into it. For months, American pilots had been forced to choose between two losing options. Now, a third path appeared. Brief, narrow, but real. The aircraft could reverse when it needed to. Not sooner, not later. Exactly then.
The first engagement did not unfold cleanly. They never do. The P-38 entered from altitude, fast but not untouched by turbulence. The Zero reacted immediately, rolling away and diving. This was expected. This was practiced. What was not expected was the response. When the pilot rolled to follow, the aircraft moved at once. There was no soft moment, no lag while the system loaded. The ailerons bit immediately, and the nose followed without argument. That single change compressed the timeline. The Zero pilot had committed based on old timing. He reversed expecting space that no longer existed. The P-38 stayed inside the turn just long enough, not to outcircle, to arrive early. The firing window opened briefly. It closed just as fast. Rounds connected because the geometry aligned sooner than it should have. There was no pause to assess. 2 more zeros were already descending. Energy states collapsed. Doctrine evaporated. The pilot reversed again. Hard. Low. The aircraft did not fight him. It did not feel heavy. It did not feel delayed. It responded like a machine under direct command instead of one negotiating through slack and inertia. Each input translated cleanly. Each reversal landed where the pilot intended. The engagement became chaotic because the old rhythms were gone. The Zero pilots were no longer reacting to predictable pauses. They were reacting late. One overshot. Another bled speed trying to force a solution that had stopped working. The P-38 did not gain agility. It gained immediacy. That was enough. When the fight ended, fuel was low. Ammunition was nearly gone. The aircraft carried new damage along the booms from passing debris, but it was still flying. On the ground, nothing about the aircraft looked unusual. No new surfaces, no visible changes, only a different outcome. From a technical standpoint, the act was unremarkable. A cable took load earlier than before. A control surface moved when commanded instead of moments later. From a tactical standpoint, the effect was immediate. The fight did not prove the modification was flawless. It proved something more limited and more important. The aircraft could now arrive on time.
The aftermath did not announce itself with celebration. It arrived quietly. Pilots returned with aircraft intact more often than before. Debriefings changed tone. Not confident, controlled. They did not describe new tactics. They described timing that felt right. Reversals that happened when expected. Aircraft that stopped arguing in the moment where argument had always existed. The modification spread without paperwork, not as an order, as a request. One pilot asked another why his aircraft felt different. A crew chief listened. A mechanic tried it once, then twice. The change did not create invincibility. Pilots still made mistakes. Aircraft were still lost, but the pattern shifted. Engagements that had ended abruptly now unfolded long enough for decisions to matter. Pilots who would have been forced defensive could choose, not safely, but deliberately. Japanese reports began to note the difference before American paperwork did. Zeros encountered P-38s that reversed faster than expected. Timing assumptions failed. Familiar solutions produced exposure instead of advantage. The response from Japanese pilots was hesitation. Not because the P-38 had become superior in every dimension, but because it had become unpredictable in the one dimension that mattered most: control. On the American side, the system struggled to interpret the data. Loss ratios improved, survival increased, but no formal change had been issued. Inspections continued. The modification disappeared during checks and reappeared afterward. Everyone involved understood the arrangement without discussing it. Eventually, engineers arrived. Measurements were taken, loads calculated, tests flown. The conclusion was narrow and uncomfortable. The modification was sound. It introduced no unacceptable stress. It solved a problem that specifications had allowed to exist. A revised control system would later appear in production models. Official documentation would describe it as an engineering refinement. The origin was omitted.
For the pilots, the aftermath was simpler. They flew aircraft that responded. They survived engagements that had once been unwinnable. They returned often enough to notice the difference. For McKenna, nothing changed. He kept signing logs, kept working cables, kept watching aircraft depart. The control had returned to the cockpit. That was enough.
The modification never received a ceremony. There was no announcement, no citation. In official records, the improvement appeared later as a design evolution, attributed to analysis and testing. That is how systems remember themselves. What the system did not record was the context, the months where pilots disappeared faster than explanations could keep up, the point where waiting for permission became its own kind of failure. James McKenna did not change the war. He did not redesign an aircraft. He adjusted a delay that no longer made sense once lives depended on it. The significance was not the wire. It was where the decision was made. Not in a factory, not in a committee, but on a quiet flight line by someone close enough to the consequences to recognize a pattern others could afford to ignore. The pilots who survived did not talk about innovation. They talked about aircraft that finally did what they asked. They flew differently, not because they were braver, but because they were no longer fighting their own machines. McKenna returned home after the war and resumed a life that left little trace in archives. He worked on engines. He fixed things. He did not explain himself. Years later, when historians reconstructed the change, the estimate was cautious. Dozens of pilots may have lived who would not have otherwise. No number was ever precise enough to matter. What mattered was that the solution did not wait to be elegant. It waited to be necessary. This is how adaptation usually happens under pressure, quietly, locally, without consensus. Not because rules are unimportant, but because timing is. And sometimes, removing a fraction of a second is enough to return control where it belongs.